हरिः कन्ना।
Now let's look into making a helper function. So what is that? It makes our life simple. For example, mm, if you need to make the same plots over and over again with different data sets, or want to easily wrap matplotlib methods, then we can use we can create a function, and that function can be called out whenever you want to plot a graph. Okay, let's take one example. I'm gonna say making helper functions. One, yeah. So first I have defined a function. So as usual, defining a function uh, in similar to the Python. So def keyword we'll use, and after that the function name. So my plotter, and I'm gonna give the parameters to it. So I'll say ax data 1, data 2, and param dict underscore dict. And now I have to build a function, what all activities that function should be done. But before that, let me add, yeah, a helper function to make a graph iteratively, or make a graph. Yeah, that's enough. Then, so let me define what it should do. So ax dot plot, and inside that I'm going to give the respective parameters, data 1 and data 2. Here what I'm doing, I'm providing a values that to be plotted on x array, that's array 1, and data 2 array 2, that's for the y-axis, and then third one is additional parameters, that's a param dict. Clear? So now let's return out. That's it, our function is ready. So our function is ready. Now we have to let's call the function. But before calling the function, we should have a data. So that's why we will create our data array. So let's create data arrays. Okay. Let's create data arrays. The first one will take total 4 variables names: data 1, data 2, data 3, data 4. So we'll use numpy arrays, numpy dot random dot, I'll use a rand n method, and 4 to 100. 4 to 100 is what these many random numbers to be generated. So it makes 4 random data set. You see that these are the 4 random data sets or random data arrays. So once this is done, so next thing to be done, okay, let me execute this. So just to cross check the values, you can check print data 1. This would be your first array, you see that, and second one, print data 2. This is our second one. So you're getting values in between, a lot of values, so almost 100 values we got, around approximately. Clear? We got the values, that's what we were telling here. So this is the difference, and then this is the number of fractions to be done. Okay, number of fractions to be done between. So these are all obviously an improper fractions. These are not proper fractions. Anyway, similarly, the same will be applicable to other variables also. These four are arrays. So now let's plot. So my plotter, that's what is our function, and inside that, as we have, and so we have seen the data. Now we have to define few more things. That's the fig, and then a tuple of ax1 comma ax2. Clear? So now let me add a plt dot subplots this fig and ax objects to be created. So that's what I'm doing, subplots, and inside the subplots I'll give 1 comma 2 grid, and after that I'll go for the fixed size will go with the same one. We'll take a tuple of 5 comma 2.7 and execute it, and this is your figure. This is your canvas layout. So now let's draw our plot using function. So my plotter, and let me give ax1. You see that? Sorry, you'll find ax1 comma different variables, data1 comma data2 comma, and I have to give the I can give a, a dictionary. So marker a key value, and then after that x is the x value. So it's, and let me close this and execute it, and here it is. The plot has been created successfully, and you see that the plot has been created. So it's a line 2D object, and which has been stored at this location. This is hexadecimal memory location. Okay, that's done. So now let me take this and put it back into the main code and paste it here and execute it, and here is the magic. Clear? This is the plot we are expecting. And similarly we have other one. So this time another plot we're going to create with the slightest modification. So my plotter, and this time I'm going to take ax2 and data 3 comma data 4, and then same marking. This time I'm going to use a different marker. So this marker would be O. Clear? O. And execute it. So another has been plotted at different location. It's 59510. This is 5FD90. That's okay. Let me copy this and put it back into our main code and then execute it, and here is the magic. See, when you put the O, we got this kind of shape. When you put the X, we got the X's at the end. You see that? This is how we can use this with the slightest modification. We can create whatever types of figures that you want. You can create each and everything. So that's what is making a helper function. So note that if you want to install these as a Python package or any other customizations, you could do that if you, after creating your modules of graphs. So you have to put it in a one certain place, and then you have to attach that directory to your Python, so that you can directly either you directly import that module and then import this function from that module. That is possible. Or else if you want to a specific one, you can put it in the same folder where other files are there, and you can import directly. So there are different ways of customizing your modules and then functions, so that if you have no idea how does it work, you watch my intuitive Python for you course. I have clearly the every minute aspect of this I have explained there, and that too with the practical demonstration of each and everything. I urge you to watch that video.